In the last episode, we see how humans and robots teamed up on the moon in year 2033, testing habitats, mining ice, and proving we're ready for long-term lunar living. Year 2034, this is Mission Argonaut 1, Earth's first robotic emissary to Mars, sent ahead of the crewed voyage of 2038. How will Argonaut make the 225 million kilometer trip across the void? And in what way will it pave the path for humans to walk on Martian soil? Fueled by high-efficiency chemical rockets, Argonaut I will depart Earth's orbit on the 5th of June, 2036, riding a Hohmann transfer that takes 7 months of silent coasting through space. During that time, its twin-star trackers and gyroless attitude thrusters will keep the spacecraft pointed just right. While it's 50 square meters, solar arrays soak up sunlight to charge batteries for night passes behind Earth and Mars. Once it leaves Earth's protective magnetosphere, Argonaut I will rely on a small radioisotope heater to keep delicate instruments warm. How will it manage power when dust storms on Mars block the sun? 4 folding solar panel sack capable of 500 watts at noonday will work with 2 200 watt-hours lithium-ion batteries. And a pair of 3 kilowatt radioisotope heater units will prevent critical pipes from freezing in the bitter cold. On the 15th of January, 2037, Argonaut I will fire its main engines for the Mars orbit insertion burn, slowing by 4.5 kilometers per second to slip into a 400 by 400 kilometers circular orbit above Utopia Planitia. What comes next is a ballet of precision maneuvers. The lander separates from the orbiter, jettisons its interplanetary solar arrays, and points its heat-shielded nose at the red planet. At Mach 2.2, it will deploy a 14-meter supersonic parachute, then fire retro rockets in the last 10 meters to settle within 50 meters of the science cache site, chosen by Earth-based geologists. Touchdown comes on the 20th of March, 2037. How will Argonaut I survive the first Martian night when temperatures plunge below -100°C? Its fold-out solar panels will hunker beneath a thin layer of dust-resistant coating. Every morning, an electrostatic dust-shedding system will vibrate the panels to shake off regolith. Inside, a warm electric blanket of heater cables will keep propellant tanks above -20°C, ready for the critical return launch. Immediately after landing, the 6-wheeled rover Pathfinder 2 will unfold its rocker bogie suspension and deploy its solar shoulders. Weighing 320 kilograms, it's armed with stereo cameras, ground-penetrating radar, and a drill that bores 2 meters into the surface. Will it find ice or hydrated minerals beneath the iron oxide crust? Over its first 30 sols, Pathfinder 2 will map subsurface ice pockets, measure radiation levels with its RAD-X sensor, and send back soil mechanics data to guide the design of the human landing craft. Data travels from rover to lander via a UHF link, then hops up to the Argonaut orbiter on X-band, before streaming back to Earth. With up to 22 minutes of delay each way, the rover's onboard AI must make split-second hazard avoidance decisions. When a dust devil whirls across its path or a steep ridge looms ahead, Pathfinder 2 will pause, consult its maps, and choose a safe route, then send a status update in the next communication window. While the rover explores, Argonaut I's Mars Ascent Vehicle MAV stays tucked beneath a protective cover. How will the MAV endure 6 months of dust storms and extreme cold? A sealed environmental control module will maintain 10 kilopascals of pressure and keep its hypergolic fuel tanks at +15°C. The solid fuel first stage and bipropellant second stage will wait patiently until the return window opens. As Sol 60 approaches and global dust storms dim the sun, Argonaut I will switch off solar generators and switch on its radioisotope heater units and battery, ensuring both rover and orbiter never lose power. On Sol 90, the 18th of June, 2037, Pathfinder 2 will finish collecting the final rock cores. How will it deposit them near the MAV? Using visual odometry accurate to a few centimeters, It will place each titanium sample canister into a loading chute on the ascent platform, then back away to a safe distance. The countdown to liftoff begins on Sol 120, the 18th of July, 2037. What checks will be run before ignition in the thin Martian air? 30-minute hot-fire tests of the reaction control thrusters will confirm nozzle integrity. Instrument warm-ups will verify telemetry channels. A robotic arm will brush away lingering dust at the engine bell. When all lights turn green, the solid fuel first stage will ignite, climbing to Mach 4 in 60 seconds, before separating and letting the bipropellant second stage finish the job, pushing the MAV into a Mars parking orbit with 1.5 g of acceleration, well within human comfort limits. 2 weeks later, on the 2nd of August, Argonaut I will circularize its orbit at 400 kilometers and release the sample capsule. Pointing its heat shield toward Mars, it will fire a 200-Newton thruster to set a trans-Earth trajectory with 3.8 kilometers per second of delta V. How will astrophysicists time the burn to avoid a communication blackout during solar conjunction? By aiming the injection so the capsule spins its deep space coast on the opposite side of the Sun from Earth, the mission ensures at least daily windows to monitor critical health data. The 6-month return cruise begins. With Argonaut I's PICAX heat shield variant standing guard against micrometeoroid erosion, only 0.1 millimeters lost per year, while onboard sensors track capsule integrity. If a reaction wheel fails, magnetorquers and sun sensors will take over attitude control, and a backup thruster array stands ready should more serious anomalies arise. On the 28th of February, 2038, the sample return capsule lines up for Earth entry at 11 kilometers per second. What G-forces will it face? Over 120 seconds of atmospheric braking, it will endure up to 14 G. At Mach 1.3, a triple canopy parachute system deploys to slow descent to 70 meters per second. Solid fuel retro rockets fire in the last 2 meters to cushion the touchdown within 500 meters of the Utah Test and Training Range site. At 12:04 Coordinated Universal Time on the 2nd of March, 2038, the capsule's belly crushes into soft desert soil. Recovery teams standing by under the expected trajectory will secure the 15 kilograms of Martian samples within minutes. Those canisters will slide into mobile clean labs, isolating them from Earth's microbes. Back on Mars, Pathfinder 2 is not done. It will embark on an extended traverse 100 kilometers from the landing site to a nearby canyon network carved by ancient floods. How will it survive the brutal Martian winter night? By entering low-power hibernation and using its RHU heaters, it will wait out 6 weeks of low sunlight before spring returns. With Martian soil and rock samples safely in Earth labs, scientists will unlock the red planet's geologic history and refine life support systems for the human mission of late 2038. What perchlorate concentrations will they find? And how will those shape water processing designs? What radiation dose did Pathfinder 2 record? And how thick must spacecraft walls be to shield astronauts? How extensive are subsurface ice pockets? And what will that mean for in-situ resource harvesting? Mission Argonaut 1 stands as the template for every future robotic precursor. A flawless choreography of launch, 7-month cruise, precision landing, rover deployment, sample caching, ascent module liftoff, 6-month return, and Earth recovery. Its success proves that humans need not venture blindly. Instead, careful scouts can clear the road ahead. As mission control pore over every torque measurement, every dust storm sensor reading, and every soil spectrum, the world readies itself for the crewed journey, a 1-year round trip with only 30 sols on the Martian surface. In early 2038, astronauts will don their suits and climb into the Orion-derived lander. They will descend exactly where Argonaut I and Pathfinder 2 paved the way, stepping onto ancient lakebeds, collecting new samples, and planting the first human flag on another planet. The story of Argonaut I ends not at touchdown, but at the moment when human boots rustle the red dust for the first time. Its legacy lives on in every data packet, every rock sample, and every image beamed back across the void. In the silence between worlds, the mission whispers its message. We can reach out, we can prepare, and we can return together. In the next episode, we will see how the moon gets its first modular base in year 2035, powered by solar, built for the future.